Alrighty, let's see what we got here. Sum of GCD greatest common divisor form pairs. Another GCD problem. Okay. You're given an integer array nums of length n. Construct an array prefix GCD where for each index I, let mx sub I equal the maximum of nums at 0, nums at 1, all the way to nums at I, so all the values up to the ith value. Prefix GCD at I equals GCD of nums at I and the maximum of those values. After constructing the prefix GCD, sort prefix GCD in non-decreasing order. So roughly ascending with ties. Form pairs by taking the smallest unpaired elements. Form pairs by taking the smallest unpaired element and the largest unpaired element. Repeat this process until no more pairs can be formed. For each formed, my God, what the hell is going on? For each formed pair, compute the GCD of the two elements. If n is odd, the middle element of GCD array remains unpaired and should be ignored. Return an integer denoting the sum of the GCD values of all form pairs. What the fuck is this? This is absurd. Okay, 264. So construct the maximum. Okay, let's try it. Let's see if I can't figure this out. So nums 264. So the maximum up to the ith is going to be 266. The prefix GCD up to the ith is 2 is the GCD of the current value at the ith index and the maximum value up to the ith. So the prefix of 2 and 2 should just be 2, 6 and 6 should be 6, 4 and 6 should be 2. Okay, sort the prefix GCD and non-sort would make this 226. Form pairs by taking the smallest. Okay, 2, 6 is the only pair that you can make. Repeat this process until no more. For each form pair, compute the GCD. So GCD of 2, 6 is just going to be 2. If n is odd, the middle element of GCD. If the length is odd, the middle element is unpaired and should be ignored. So the middle element here is going to be 2. It's going to be ignored. Okay. Return an integer noting the sum of the GCD values of all form pairs. So the sum should just be 2. Okay. Let's try example 2. Nums is 3628. The maximum up to the ith element is going to be 3668. The prefix GCD up to the ith element. So 3 and 3 is 3. 6 and 6 is 6. 2 and 6 is 2. 8 and 8 is 8. So the pairs will be sorted would be 2, 3, 6, 8. Pairs will be 2, 8, and 3, 6. GCDs of those would be 2 and 3. So sum is 5. Okay, you have 10 to the 5th elements. Each element can be 10 to the 9th. Okay. This is kind of absurd. Like, I assume there must be some sort of pattern that you would use. Why are they making this process so complicated? Hmm. I mean, is there a way to not compute some of these steps? Particularly the fact that you have to create the prefix GCD, pair them up, and then calculate the GCD of the pairs. So it looks like it's 10 to the fifth, right? So that means it has to be, it can't be n squared time. It has to be n log n or linear time. Huh. Do, 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 do. What would I do here? Do I just want to manually do it for all the elements? Literally do every single step here? Prefix GCD. All right, let's go ahead and get some. I think it's Euclid's method is the fastest way to get the greatest common divisor. Fastest Python greatest common divisor method. I think it's like subtracting. No, it's really math.gcd. Okay, it supports an arbitrary number of arguments. We'll see whether or not this is workable, or I need to do some sort of optimization. But let's go ahead and just do the naive approach here. Let's say large just as an array. I guess I can start with the first element and nums. Actually, the elements are positive. So let's say current largest is 0. For every value in the nums array, if that value is greater than the current largest, current increases to that value, and then largest appends that current largest. Okay, so that creates the maximum. And now I just need to do the GCD. So say a prefix GCD is an empty array for every value in nums. I guess I could have done this. I guess I don't need to store largest array. I just can use the current value. I can just use the current value as what I would be taking the GCD of for maximum and nums at I. So prefix GCD append math.gcd between the current largest value and this current value. Current value up to this point, the current maximum up to this point. Okay. And then I would do sort, right? And then I would just do pairing, so the first and last, right? So the answer is some summation for index in range. Yeah, I guess I'll just use indices here. don't think I can use a for each loop. For index I and range n, I guess it should be n divided by 2, where I is equal, or n is equal to the length of the nums. Then answer appends, or no, answer adds math.gcd of the prefix at this ith, prefix gcd at this ith, and prefix gcd. I guess I could just do like negative I, right? It's going to be 0 and negative 1 to index from the back of the array. So it'd be negative 1 minus I, and then return the answer. This should work. The question is whether or not this is fast enough. Okay. Yeah, I don't know, to be honest, what this was wanting me to do in terms of optimization. I mean, seems like there were some way to optimize this to be considerably faster, as in half the speed. Like, what is the optimization here? I mean, it feels like the prefix GCD array values would be kind of random because you're using maximum up to the ith index, and that could be like anything really. So, like, is there some sort of pattern that you can somehow skip over? Like, this is the thing, right? This, well, is this thing? The prefix GCD dot sort is what changes the algorithm from like O of n kind of to O of n log n, depending on what the speed of the GCD function is. I'm guessing the GCD function is log of k, where k is the size of the thing, right? Maximum size. I'm pretty sure. So log of 10 to the ninth, which is like 9 instructions or whatever, which is kind of constant compared to n. So yeah, like prefix GCD here is going to make this into an n log n algorithm. So my sense is, assuming that there is some sort of speed up here between kind of whatever I did and whatever they did, it relates to not sorting. It relates to not sorting or doing some sort of optimization. What other optimizations are there? Not sorting, maybe doing a lot less prefix calls, prefix or not a lot less GCD calls. What else is there? I mean, if I were to cache, if I were to cache some of the GCD calls, maybe that would help. Like if I were to somehow cache the GCD 28 call so that if there's this done multiple times, it just gets a single return value. I guess, what was the, like, there's a function that can maybe do a wraparound. guess I can just try to ask anything here. How would I cache the calls to GCD so that if there are multiple of the same, it can save time by taking a previous result? I guess, I mean, my assumption would be I make my own helper function for the GCD call that caches. I think this is the syntax for it. It would be something like cache, like get GCD, and then like AB. And then it'll just do return math.gcd prefix GCD at I prefix, or I guess this would be AAB. I think that's how you do it. I'm just going to double check. I think cache is the call. Cache is the, not call, but the, is the tag. I'm not sure what the actual functions tools. LRU. LRU is linear. What does LRU stand for? Lookup relational cache decorator. Okay, it's not a tag, it's a decorator. Wraps your function up on a lookup table in memory, making duplicate calls, executing constant time. Drop the decorator directly on top of your function's definition. Yeah. Import LRU cache. Caching the built-in math.gcd, because math is built in, you cannot decorate directly. Instead, yeah. Okay, yeah, that's what I did, right? Well, I use decorator cache instead of LRU cache. Yeah, and then I have to worry about the sorting of it, right? So W cache always sort the inputs so that the larger is processed first. B A if A is smaller than B. And then this calls this thing, yeah. Your integers are massive, hundreds of digits long, yet the same duplicate pairs frequently. Is there a decorator that is simply cache? How does that compare with, if so, how does that compare with LRU cache? The integers are 9 digits, like up to 10 to the 9, i.e. values are up to 10 to the 9th. But there could be lots of identical calls. I misspelled cache. LRU cache. Cache. Okay, so the simple decorator that is just like cache built in to the directly into Python is faster, is simpler, faster alias for LRU cache max size equals none because it does not track cache sizes or evict old entries. It has a slightly cleaner internal code op path. Okay. There's a higher chance of memory leak with that. Yeah. Requires the latest version of Python or later versions of Python. Where 9-digit integers do not use cache or LRU cache, standard micro benchmark shows that the overhead of looking at parameters inside of Python dictionary is roughly the same speed as executing GCD directly in C. Because math.gcd finishes natively in less than a microsecond. Caching will not save you time and will instead aggressively consume your RAM. Yeah, okay. So yeah, this is just maybe too into the weeds. Or not into the weeds, but the values are too simple or too small for it to be the difference or be an optimization. So I get the sense that it has to be this sort. Well, no, I get no sense, but my reasoning by process of elimination is I somehow cannot or somehow don't need to sort. So if I didn't sort this, right, if I just had prefix GCD be 3628, and I just try to do pairings, this would be 3 and this would be 2. Okay, let's think about this. 3628. If it's unpaired, it's gonna be 3. Like what is the worst case scenario? Like it pairs 2 and 3 and pairs 6 and 8. Pairs 2 and 3 gets 2, 6 and 8 gets 2. Yeah, that would be wrong, right? But if it was something like 3 and 6, 2 and 8, then yeah, that pairs correctly. I wonder, greatest common divisor. I mean, is there a possibility that the first GCD value has to in some way be a factor of the largest GCD value of this chain? Like, could it be like 3, 3, 4, 6, 8 somehow? 3, 4, 6, 8 rather than 2, 3, 6, 8. Like 3, 4. I mean, if the array was literally 3, 4, 6, 8, then the GCD values would be 3, 4, 6, 8. And then you have to pair the 3 and 8 with GCD value that's 1, and the 4 and 6 GCD value that's 2. 3, 4, 6, 8. All right. This is just I don't know, man. I've never seen any sort of simplification in this manner. So I'm just going to go ahead and say, okay, I don't know. Above code simply uses the kind of built-in GCD function of Python, along with literally yeah, I guess literally is the word I'm looking for. Literally coding each step to come up with the answer. Literally find the maximum at each index, take the GC of that maximum and the current value at that index, creating the prefix GCD array, sorting it, and then doing the pairing and summation of the GC of the pairs. Nothing fancy. I believe there is some simplification to possibly not need to sort, i.e. calculate the answer summation by some logical deduction about the GC values unsorted. But I could not find that optimization. That belief is strictly based on the performance of this code, which is 2 times as slow as the fastest. There has to be some sort of jump. Time complexity is going to be O of n log n in order to sort the imputed prefix GCD array. Oh, well, yeah. I don't think I really need to explain much more than that. Yeah. The computation of GCD between A and B in Python should be fairly fast, i.e. O of log k, where k is the maximum value of A and B. So I mean, it's like n log n and then n log k. So it should be, I don't know, n times log n plus log k maybe. Base complexity is going to be O of 1. Or no, O of n, since we have a prefix GCD array in use in order to calculate the later values. Okay.